Hello, my name is Viyat Mehta and today I will be talking through how to navigate through virtual testing and LS-DYNA with Oasys Suite for enhanced vehicle safety. This is an overview of complete set of workflow tools which can be utilized by CAE and vehicle safety teams to address the challenge posed by the introduction of virtual testing protocol. Historically, vehicle crashworthiness regulations and NCAP safety ratings have been based on physical testing alone. This is changing with the advent of virtual testing protocol. In virtual testing, a simulation model is validated against a physical test, and then if the validation is deemed acceptable, variations of the test are rated based on simulation results called virtual load cases. Initially, these virtual load cases will consider variation in impact angle or occupant sitting position. In time, they will accommodate the introduction of human body models to augment the traditional use of anthropomorphic test devices (ATDs). Virtual load cases aim to improve the safety of vehicles in greater number of representative real-world scenarios and for a more diverse range of people. Virtual testing promises significant improvements in vehicle safety, but it also represents a new paradigm for the vehicle safety industry and especially for LS-DYNA users. Previously, CAE teams used LS-DYNA to predict the behavior of vehicle design in preparation for the physical crash test assessment. With virtual testing, LS-DYNA simulation is part of the actual assessment. For LS-DYNA users, this is like switching from doing homework to prepare for an exam to being in the exam hall itself, doing the final exam. The stakes are higher and the consequences are greater. The Oasys LS-DYNA environment is a key part of the overall CAE workflow for many LS-DYNA users, widely used to ensure quality models and results. This webinar presents our method of reviewing the requirement of virtual testing protocols and identifying the various challenges they present. We will then explore the Oasys LS-DYNA environment software solutions developed in response to those challenges. Although there are differences between the requirements of the various regulatory and NCAP protocols, the Euro NCAP and C-NCAP protocols published to date share some common requirements that can be grouped into following categories. Quality. In order to provide a meaningful basis for validation against physical test data, LS-DYNA simulation model must meet a set of quality criteria, including limit imposed on hourglass energy, mass scaling, and termination time. Correlation. The main method of validation is an objective comparison of time history signals from various sensors placed on the ATDs and vehicle structures in the physical test and their corresponding entities in the LS-DYNA model. For both the Euro NCAP and C-NCAP protocols, this assessment of correlation must be completed according to ISO TS 18571:2024. Injury assessment. In virtual testing protocol, injury assessment criteria are compared between simulation and physical data as part of the validation requirement, with Euro NCAP's validation criteria 2 and C-NCAP's correction factor A. In the Euro NCAP protocol, validation criteria 2 impose an acceptability limit on the differences TAC between the ratios of the injury metrics and their limits when compared between simulation and physical test. The C-NCAP protocol specifies a correction factor A based on the ratios of the injury metric and their limits and applies it to the overall score of the protocol. Data submission. In order to ensure integrity of the assessment, simulation results are required to be submitted to the testing authority, in advance of the physical test. Euro-NCAP requires the submission of result data in ISO-MME format, whereas C-NCAP is less specific and indicates that LS-DYNA bin-out files are also acceptable. Both virtual testing protocols also require the submission of videos showing animation of the simulation viewed from a specified set of camera angles. These virtual testing protocol requirements present significant new challenges for OEMs and suppliers. Good correlation has become mandatory. Good correlation between LS-DYNA models and physical tests has always been beneficial in the vehicle design process. However, before the advent of virtual testing, CAE team could rely on making conservative assumptions in their LS-DYNA models. Previously, engineering for redundancy was a workable strategy, but now it is no longer acceptable. If the physical tests perform better than predicted, it must perform exactly as predicted or within the protocol limits. CAE and vehicle safety team need new correlation tool to perform rapid and accurate correlation analysis with the ability to analyze and investigate causes of poor correlation. Collaboration between CAE and vehicle safety teams. With the advent of virtual testing, CAE teams will need to work more with physical testing data, and vehicle safety teams will need to work more with simulation data. They will also be working with many more metrics than previously. New tools are needed to aid this increased communication and collaboration. Quantity of LS-DYNA analysis. The virtual testing protocols specify a larger number of load cases to be analyzed, resulting in a significant increase in the volume of data to be managed. Virtual testing software solutions should be designed to facilitate this increased volume of data processing and storage. Format and quality of data. The protocol requirements place increased responsibility on CAE and vehicle safety teams to ensure that the quality of their LS-DYNA models is sufficient and that the format of the data submitted is correct. Tools are needed to aid model quality checking and reformatting so that data submission is successful. So how do software providers respond to these requirements and challenges? Let's take a look at solutions we have developed. Virtual testing solutions were developed for the Oasys LS-DYNA Environment software, which is a key part of the overall CAE workflow for many LS-DYNA users, widely used to ensure quality models and results. Many of you will be familiar with our core suite of products. We have Primer, your preprocessor for LS-DYNA. We have D3plot and THEIS for visualizing and processing your results. And we have Reporter for automatically producing reports and presentations. We also have some other tools to augment the core suite, helping you to automate tasks and communicate results. We have Shell, a comprehensive LS-DYNA submission tool, which also provides functionality for running our applications in different ways. For example, automatically post-processing multiple jobs in one go. We have scripting capability embedded across all applications, which makes it easy for you to automate and customize. We have D3plot Viewer, the web-based lightweight result viewer for communicating results. This is now joined by Report Viewer, which provides an easy and convenient way to share reports with 3D enabled content. Any LS-DYNA pre and post processor offers a range of tools that can be used to configure and interrogate LS-DYNA models. However, the basic tools are not always customized for LS-DYNA or for specific load case. You may need to perform many manual steps to process your results, which can be time consuming and prone to error. Scripting APIs can be used to create tools to automate tasks, but this requires time, resource, knowledge, which is not always available. For these reasons, The Oasys LS-DYNA Environment virtual testing solutions were developed within the existing Workflows framework. Workflows is a powerful framework that provides Oasys LS-DYNA environment users with customized tools that work seamlessly from pre-processing through to post-processing, providing results quickly and reliably. While building LS-DYNA models in the preprocessor Oasys Primer, workflows enable CAE team to tag models with user data, which is leveraged in the post-processor Oasys D3plot, THIS, and Reporter to surface relevant results and insight. I will talk more about this workflow user data later. The Oasys LS-DYNA environment now contains a set of integrated and complementary virtual testing workflows to provide a comprehensive solution for CAE teams. These are Automotive Assessments, VTC Quality Criteria, SimVT, LS-DYNA to ISO-MME, VTC videos. The Oasys LS-DYNA environment supports the published Euro-NCAP and C-NCAP virtual far-side impact protocols, and the solutions have been developed in a way that will facilitate support for the various other protocols due to be published in coming years. Let's take a closer look at the solution we developed for each of the protocol requirements and see how they address the challenges identified. Here is an overview of virtual testing workflows. Let's talk through the steps. It begins with model creation in Primer. Next, the automotive assessment tools is used to label your occupants and structures, ensuring that you have requested all required outputs before running the simulation. After running the simulation, the VTC quality criteria check is used to ensure that simulation meets the quality criteria specified by the protocol. If it doesn't, then you will need to update your model and rerun the simulation until it passes the quality criteria. CAE teams will need to work hard to perform validation with in-house test results to align with simulation results. SimVT and automotive assessment workflows are used at this stage to automatically calculate the sensor ISO scores and injury scores to highlight any that fails to pass validation criteria. This gives you opportunity to address any problem areas before submitting the results. Once you are happy with your simulation model quality, you can use LS-DYNA to ISO-MME to convert your results to ISO-MME format specified in the protocol and export the required animation using VTC videos. Once results have been submitted, the physical test is performed. Then the test data is submitted too, so that it can be correlated. For the Euro NCAP VTC protocol, if the server validation fails, then you will be able to make some adjustment to the boundary condition in the model to match the initial condition of the physical test. SimVT can be used to help you identify any discrepancies between the simulation and test curves, and it can be used to inform you if the boundary condition adjustments were sufficient to pass validation criteria 1 before final resubmission. So now you have an overview of the virtual testing workflow. Let's take a closer look at the key stages. To provide greater flexibility, the individual protocol requirements are separated into distinct workflow tools. However, they all share some common parameters, which are defined in the Automotive Assessments workflow tool. For LS-DYNA users, this is the starting point for virtual testing. The Automotive Assessments workflow in Oasys Primer is used to map LS-DYNA model entities to sensor channels. In the tool, select the crash test of interest, confirm the occupant and structures metadata, and then save the user data so that it can be reused automatically for the duration of your vehicle development. Many protocols are supported, including the latest virtual testing protocols from Euro NCAP and C-NCAP. As you can see, labeling occupant entities can be done with just few clicks, thanks to the support for many common occupant models with default entity IDs and database history titles predefined. The occupants and structures required by each protocol are displayed, making it easier for you to check that all necessary entities are labeled correctly. Let's explain user data. Once saved, the Automotive Assessments user data is automatically adopted by the other virtual testing workflow tools, saving the need for it to be redefined repeatedly. Given the large quantity of LS-DYNA analysis required for virtual testing, it is essential to have a convenient system for managing user data at scale. Workflow user data can be saved to JSON files. The Oasys LS-DYNA environment will automatically locate relevant user data in JSON files located in the same directory as the LS-DYNA model or in parent directories. This option is particularly powerful because it only requires Oasys LS-DYNA environment user to save user data once, and then those data can be reused throughout a vehicle design program for multiple LS-DYNA models and load case variants. Application preference provide control over the number of upward directories that will be searched for user data files, and flexibility is permitted in the name of directory used to store user data. In this way, CAE teams can incorporate user data seamlessly into their LS-DYNA analysis storage without contravening their organization simulation data management rules or requirements. Next, we have VTC Quality Criteria. The VTC Quality Criteria workflow tools enable CAE teams to perform the quality checks required by the Euro NCAP and C-NCAP protocols. CAE teams can generate a report at the end of each LS-DYNA job using the automation application Oasys Reporter, as well as a summary page showing the overall VTC quality criteria results. The report also contains graphs for each of the quality criteria with colored datum to indicate clearly whether individual quality criteria have been met. LS-DYNA users can also open THIS to view the VTC quality criteria results in an interactive session for more detailed inspection and investigation. The next workflow is SimVT. The SimVT is designed to make it easy to correlate LS-DYNA simulations against test data. This inspired the name. Additionally, SimVT is a vital tool to help vehicle safety and CAE teams meet the demands of the new and upcoming virtual testing protocols. SimVT can be used interactively in Oasys THIS for correlating any combination of LS-DYNA models, ISO-MME data, or CSV data. And in Oasys Reporter, validation reports can be generated automatically, which summarize the correlation performance against the virtual testing protocol's validation criteria. The first step is importing test data. ISO-MME test data can be imported into SimVT so that it can be correlated with LS-DYNA data, which is automatically imported if Automotive Assessments user data is defined. CSV data is also supported for added flexibility. As well as performing general correlation analysis, SimVT is designed to support virtual testing protocols. In SimVT, you can select from a range of protocol options, which configure all the channels you need to perform each protocol validation. Some channels require derivation, such as the world seed rip deflection, and these channels are automatically derived and added to list of available channels, saving you time by removing the need to manually process derived curves. Let's look at correlation setup. SimVT makes it easy to select which channels to process, or you can simply correlate all the available channels. correlation is quick and the correlation results are displayed in a table, which makes it easy to interrogate and interact with the correlation data. By toggling their entries in the table, the corresponding correlation graphs can be plotted individually or in group based on their location or object channel codes. If the virtual testing protocol is selected, the ISO scores for sensors, for example the head accelerometer, are automatically combined using the correct weighing method according to the protocol. Dealing with inconsistent data. As mentioned previously, SimVT supports data from different sources. It's not uncommon for this data to be inconsistent. For example, the ISO-MME channel codes may differ in how they are labeled. This is one of the many challenges vehicle safety teams face when carrying out virtual testing. SimVT overcomes this with customizable channel matching rules. Here, simulation and test data channel are matched using custom channel matching rules to treat 0 and P filter class codes equivalent and ignore the ISO-MME position code. Another common inconsistency arises from test houses adopting a different sign convention or providing the result in non-standard unit system. SimVT makes it easy to apply corrective operation to multiple channels at once by expanding the operation menu to reveal set of operation fields. Operations can be used to scale and offset the curve axis as well as to apply additional filtering to both the simulation and test curves to make them consistent before correlating. This saves time when handling data with inconsistent units or if the sign conventions are reversed. All of the correlation setup, the selected protocol, channel matching rules, and any corrective operations can be saved and restored using SimVT settings file. This helps CAE and vehicle safety teams perform the large quantities of correlation analysis during virtual testing. The saved settings can be reused and mapped onto multiple simulations and test models, as well as providing the basis for automated reporting with Oasys Reporter. Let's take a quick look at automated reporting. As well as using SimVT interactively in THIS, it can be used in Reporter to automatically generate a report of the validation criteria performance. Here you can see the summary page for the Euro NCAP virtual fireside protocol. The mandatory and monitored sensor scores are all passing validation criteria 1, but the simulation duration check has failed because LS-DYNA terminated before the required 20% beyond the time of maximum head excursion. This tells the CAE team that they need to run their simulation a bit longer before the results can be accepted. As with the conventional occupant safety protocols, the injury criteria for different occupant body regions can be assessed using the automotive assessment workflow in the Oasys LS-DYNA environment. In addition, these metrics need to be compared between simulation and physical data. In the post-processor Oasys THIS, physical test data can be imported in ISO-MME or CSV format and used as a reference for the validation calculation. Assessments for different body regions and structures can be plotted with their scores displayed in the output table. For the Euro NCAP virtual testing protocol, the ratio and difference values are also displayed. This saves a lot of time post-processing results and many assessments can be easily plotted simultaneously. The calculation process can be automated with Oasys Reporter. Here you can see the Euro NCAP far side report being loaded into Report Viewer running in a web browser. The report summarizes the overall injury scores and the performance against validation criteria too. It also contains a visualization of the head excursion and other assessment plots. Let's move on to data export. The LS-DYNA to ISO-MME workflow helps CAE and vehicle safety teams convert LS-DYNA results into ISO-MME format specified in the Euro NCAP protocol, including header metadata. It can also be used to convert relevant LS-DYNA outputs to ISO-MME for other protocols, so that CAE teams can store all their virtual testing data in a consistent format. The Euro NCAP protocol specifies mandatory header requirements for MME files and individual channel files. The LS-DYNA to ISO-MME tool allows you to save and reuse header information to reduce manual entry, and Primer and THES will automatically scan the LS-DYNA keyword files and D3HSP file to populate the required solver and simulation information, including star contact and model mass properties. CAE teams can use Oasys Reporter to automate the LS-DYNA to ISO-MME workflow for each LS-DYNA job. Along with the ISO-MME files, a report is generated to summarize the header information included in the files and to report any missing input data that prevented any individual channel files from being written. Oasys THES can be used to perform the conversion interactively and to pinpoint and resolve any omissions in the LS-DYNA model setup to ensure that resulting ISO-MME files contain all the data required in the correct format, ready to upload to the Euro NCAP VTC server, as well as providing a solution to the challenge of quality and format of data. The LS-DYNA to ISO-MME workflow helps CAE and vehicle safety teams to work together to manage large volume of data in a consistent, mutually accessible format. By adopting ISO-MME as an interchangeable format, the converted LS-DYNA results can also be used for simulation to simulation correlation analysis during the vehicle design process. With both SimVT and automotive assessment workflows accepting ISO-MME files as the reference source for the Euro NCAP VC1 and VC2 calculations, and for the C-NCAP correlation and correction factor calculations. The final component is VTC videos. The VTC videos workflows in D3Plot are designed to streamline the process of generating the videos required by the Euro NCAP and C-NCAP protocols. The tools automatically calculate the camera position required for each video, saving you time in positioning the camera from scratch. Here we can see the process of generating the camera positions automatically before making any final tweaks, like hiding the windshield parts in this model before saving the configuration for automatic reuse. Here you can see the C-NCAP VTC videos report, which was generated automatically on the cluster at the end of LS-DYNA simulation. The report provides a quick method of checking the videos in one place. We have taken a look at all the tools in the virtual testing workflow. So now let's summarize. We categorized the virtual testing protocol requirements: quality, correlation, injury assessment, and data submission, and translated those into clearly defined stages of virtual testing workflows. Alongside this, we identified some key industry challenges. Good correlation is now mandatory, increased collaboration between CAE and vehicle safety teams, increased quantity of LS-DYNA analysis, and format and quality of data. We have explored how the virtual testing tools in the Oasys LS-DYNA environment address these challenges and enables your team to work together to achieve your target. And with the support for Euro NCAP and C-NCAP protocols, we will augment and extend this solution for future protocols in the coming months and years. These virtual testing workflow tools streamlined processes for CAE and vehicle safety teams, ensuring compliance with LS-DYNA model quality and data submission protocols. Automotive assessments allows users to define workflow data once, making it easier to handle the increased volume of LS-DYNA analysis required for virtual testing. LS-DYNA to ISO-MME workflow automatically map LS-DYNA entity to ISO-MME channel codes, which saves time and reduces human error. SimVT helps CA teams monitor and meet the correlation requirements to validate their virtual test models. VTC Quality Criteria and videos help vehicle safety teams to create video files efficiently, ensuring the required format and quality. If you are interested in learning more about Oasys LS-DYNA Environment solution, please do contact us. We will be more than happy to discuss how we can help. I'd be very happy to take your questions now. Thank you.